Hey, what's up, everyone? You're probably wondering, Alyssa, why are you in your bedroom right now? Yeah, so some construction workers arrived just now to install 25 gig fiber to my Mac studio, and just need to brag about that for a minute. But which means I had to relocate to a quieter part of my house. So I apologize, everyone. Yes, this is my bedroom. Anyway, enough about my bedroom. I am super excited to introduce our next speakers. Both amazing guys from a company called Escape. They're the co-founders of the company, Antoine Carossio and Tristan Kalos. And I'm so sorry if I massacred your names. But I hate it when people introduce me. As usual, I will let them introduce themselves. And take it away, guys. I'm super excited about this talk. I can't wait to dig into this workshop on hacking GraphQL.
Yeah, thanks a lot, Alisa. Very excited to be here today and to present at the Apisecure conference. We are going to release something huge today. We're going to release an exclusive research we did about discovering GraphQL vulnerabilities in the wild. And we found a lot of very interesting results. So I'm really happy. We are really happy to share them with you. So first, a little bit about me. I'm Tristan. I'm the co-founder and CEO of Escape. We are doing GraphQL security, API security. I'm French, but I lived in 3 different countries, Argentina, the US, and Spain. I was an engineer, and I loved GraphQL, but I struggled to secure my GraphQL APIs. So I decided to build a GraphQL security company. So what is Escape? Escape is a developer tool that helps developer test and improve the security of their GraphQL APIs. And this is the first fully featured automated GraphQL security tool. And we have an in-house research team on the topic, which is why we created this research that we present you today. So first, you might wonder what is GraphQL, or you just heard about it, but you don't know exactly how it works. So I'm just going to cover that very quickly so everyone can understand what we did for real. So GraphQL is a query language for APIs. It's been created by Facebook, and basically it allows you to ask an API for precisely the data that you want and get specifically the result that you asked for. Think of it as an SQL, but instead of talking to databases, you talk to APIs. It's seen a tremendous adoption in the past years. We have big companies like Netflix, the New York Times, PayPal, Volkswagen. All those companies started adopting GraphQL for huge projects that have a huge impact on their development and that handle also a lot of sensitive data and sensitive critical business tasks. So GraphQL has requests, which are queries used using the GraphQL language. And this is quite a complex language with a lot of different identifiers, such as queries, directives, parameters. So there is a full-featured language in the hood in GraphQL, which is pretty complex. So why is GraphQL vulnerable? Well, first, since it's a full-featured language, it leaves way more space for creating, crafting malicious requests. Whereas in REST APIs, you have parameters. In GraphQL, you have a whole language that you can play with to abuse the server.
Oh no, it looks like we may have lost Tristan. No!
Oh, no way.
No, it's okay.
He's back. Okay. All right. Just kidding.
Yeah.
False alarm.
Yeah. Am I still there?
You're a little choppy. Let's maybe give it a few. Let's give it another try.
Okay.
I'll stay on stage just in case.
What? Where did you lose me?
Oh no. Oh, there we go. Just like a few seconds ago. You're fine.
Okay, excellent. So yeah, as I said, GraphQL is a full-featured language that you can use for exploiting and creating malicious requests instead of just playing with parameters in a regular REST API. But also, GraphQL, as its name suggests, is a graph. So it's prone to access control problems. Because if you want to secure sensitive data, you have to secure all the paths inside of the graph that leads to this sensitive data. So it's very hard to secure. So the goal of this talk is how we manage to discover, exploit GraphQL vulnerabilities in the wild and in public GraphQL APIs just by scanning the internet. So I will divide this talk in 3 parts. First, I will explain how we found GraphQL endpoints in the wild internet, how we detected them. Then, what was our method for testing endpoints for advanced security flows? So I mean, not just headers, misconfigurations, but also very in-depth vulnerabilities that we were able to detect. And then I will explain, of course, the results, the most interesting part, which are the results of our study about public GraphQL APIs, vulnerabilities, and security flows. So let's get started. How to find public GraphQL APIs, public GraphQL endpoints on the internet. So the first step was to buy a cheap list of domains, so domains that were registered, and more specifically, we filtered the domains that had the name API or GraphQL inside of them. So api.whatever or graphql.whatever.com. So that made us a list of good candidates for having APIs, for supporting APIs inside of the domain. And the second step, we used our open source.
Really fast. It looks like your deck may be frozen. This happened before. Maybe if you stop sharing your screen and then reshare it again. We're still on the why is GraphQL vulnerable slide. I don't know if that's where you're supposed to be. I just want to make sure it's not frozen.
No, it's frozen.
Okay. Yeah, try stop sharing your screen and then reshare it again, and then it should work.
Let me. Okay.
It's the demo gods. They're back.
Yeah. Yeah, I didn't praise him enough before we talk. Okay, so let's try.
There we go. All right, we got your screen back.
Yes, there for now. Okay.
Okay, awesome. Okay, all right.
Do you see my screen now?
Yep, you're good.
I hope it will get better now. So yeah, we brought a list of cheap domains with API and GraphQL in the name that gave us 1.2 million domain. And the second step was use our open source GraphQL endpoint finder, which is named Graph Finder, and which is an open source tool that allows you using subdomain enumeration, script analysis, so reading the JavaScript files and brute force to detect the GraphQL endpoints that are associated with a domain name. So I can do a quick demo. You should still see my screen right now and see my console. So I can do a quick demo of how it looks like. It's like in a Docker image. And you just point it at a domain. So here, I pointed it at escape.tech. And this nice little tool, which is, again, open source, you can try it. Don't hack Escape, please. Normally, we're secured, but please don't try. And you can point it at any domain. It will generate tasks for finding GraphQL APIs. And here we go. We found the staging API of Escape. So we could use this little tool here for finding subdomains. But there is one problem. We have 1.2 million domains to scan. So it will be way too slow to use this technique for detecting the GraphQL endpoints on 1.2 million domains. So, well, what do you do in this case? You make a faster version in Golang. So we created Goctopus thanks to Escape engineer Noe Iniger. He created Goctopus, which is a way faster GraphQL fingerprinting system. And with this, we were able to scan the 1.2 million domains in less than a day. And we now have 2,450 public GraphQL endpoints that are validated and that we know exist. So again, this is open source. You can check it out on GitHub. So now that we have this awesome list, this big list.
So I'm so sorry about all that mess, everyone. So what happened is that at that point, so we collected a lot of GraphQL endpoints and we want to test for the security, okay? So the problem when testing and automated testing in automated API testing is that the current security tools, they struggle into passing the data validation layer, the application validation layer. So actually, most of the time, they don't really test anything. I'm talking about stuff which is doing automated fuzzing, such as a WhatsApp application and so on. Since they really struggle into generating legitimate traffic that makes sense according to the business logic of the API, and therefore they are just stuck before testing the real injections and the real security issues. So this is why at Escape we developed what is called a feedback-driven API exploration algorithm, which consists in progressively trying to send really precise payload on the API, analyzing what the application gives us back, storing this data and re-injecting it later in further requests in order to progressively explore and discover the API. This is not really part of security. This is not a pure security thing. This is just API exploration, what we call feedback-driven exploration. And then when this exploration algorithm is over, we are able to generate a collection of legitimate requests, and therefore we fire them by injecting some payloads at some point and to test the security. So the scan is a two-phase scan. This feedback-driven exploration that aims to pass the application validation layer. And in the second part, we try to test for vulnerabilities into the application using the traffic we generated first. So this is on the very left, regular fuzzing, which is generally inputting random data into the application. And on your right, you can see that we have coherent data and real data that was previously found into the API, and that we are able to re-inject it. And so the query on the right makes a lot of sense because it uses a real user ID to edit the user with a real email, and it tries an injection in the password field. So this is just a very dummy example, but this is to understand the principle of feedback-driven API exploration. The second problem is that GraphQL is actually good as a graph. So this is really specific to GraphQL, and this means that there are, in fact, multiple paths, and we have to recursively explore all paths leading to a certain data. For example, here we can see the entities, the different objects in the GraphQL API, they are linked to each other in a certain way, and there are at least here 3 different paths to access the same resource, which is a strike token, which is defined in the column on the screen. Okay, so now we are wondering what to test. We are testing a wide variety of different vulnerabilities using the legitimate traffic we generated before. We are obviously testing for rate limits, testing for the limits of the query size, which is a risk problem in GraphQL. We also check for the authorization level in objects, for errors such as 500 euros and HTTP errors and so on, for information disclosure, server-side request forgery, and also request forgery, for injections, for sensitive data leaks, and so on. So we have a wide variety of checks, and you can see all the checks we are proposing, and all that was used to conduct this research too. So here is the interesting part. What are the results, and what did we discover into the wild? What are the vulnerabilities we discovered into those public APIs? So yeah, just to say that we've conducted this research through the last month. So there are those results, as Tristan mentioned before, they are quite exclusive, and we dedicated this research and for Apisecure. So we managed among the 2,000 and we managed to scan more than 1,600 endpoints. for a total, a long total scan duration. And it leads us to discover a huge amount of security alerts and pieces of detail we are going to show you now. So as we can see, GraphQL applications, they are in average quite vulnerable actually, because so we will see that into details later, but there are some specificity into GraphQL applications that make them quite vulnerable. And we can see that on average, we managed to raise around 30 alerts per application per GraphQL endpoint. Okay, so as we can see, two major things here. Actually, we found quite important amount of what we consider as medium vulnerability into those applications. And most of them, actually, they were about information disclosure and sensitive data leaks. As we can see, and this is really interesting too, there are a lot of complexity issues. So what we call complexity is really dedicated to GraphQL. It's about the rate limiting, the limit of, in terms of the fields, in terms of depth of the queries and so on. And also we have so various really advanced queries we managed to detect. Actually, we managed to detect quite a few, almost 500 server-side request forgeries and some injections, including some command injections in GraphQL API, which was, well, quite a huge issue actually. But if we break down the vulnerabilities, we can see that, as I said, most of them are about complexity. And this is due to the fact that GraphQL is a graph. You can query a lot of data at the same time, and you can do some aliasing and some batching requests. So those kind of vulnerabilities, they are at the same time, they could be considered as a feature for GraphQL, but well, this is between a feature and a vulnerability, because in some cases you can really easily generate some very complex requests that just simply does that just created denial of service on the server. And it happens quite a lot that we see some applications that are actually vulnerable to DDoS attacks due to complexity issues, which is originally a GraphQL feature. But this is why, by the way, we also propose some open source package, which is called GraphQL Armor, that is completely free, and you're welcome to contribute, and which allows developer to quickly fix and set some limits, on those complexity features in GraphQL. Okay, so indeed, so this is the slide that presents the limits of, well, batching and aliasing in GraphQL. So you can see how it works in GraphQL. You can really easily, in fact, batch multiple. So batching is the fact of sending multiple different GraphQL requests, but in the same HTTP request, whereas aliasing is in fact doing multiple GraphQL requests, but inside only one GraphQL request, which is you query multiple query or mutations inside one GraphQL request, but both of them, they could lead to security issues, actually. So the problem is that, of course, it can be used to bypass HTTP rate limiting on logging mutation and to create, for example, some kind of brute force attack. In only one request, you can try thousands of different logging combinations with user and passwords, and try simply to bypass the rate limit of the HTTP server. This is what I discussed earlier too. This is a really common vulnerability, by the way. This is called directive overloading. So in GraphQL, there is a feature that is called directive too. And you can overload it actually in order to simply DOS the server with a simple query. And this is really common, and we find this vulnerability in a lot of bug bounties, and even like major companies such as Netflix or Apple, or by default were vulnerable to this. So now it's okay, of course, because they fixed that since then. But this was a really common vulnerability that we actually discovered internally at Escape in our research team, and we have I can't remember the CVE, but we have a CVE for that. Yeah. Okay. Recursive fragments is another kind of GraphQL, I would say, feature that can cause some issues in order to create infinite recursion, for example, and then create internal server errors that by simply, reaching the limits of the server. And it happens that it happens really often that in the stack traces are actually into production APIs. Into those production APIs, having stack traces is really bad because you can reverse engineer how the API was built and all the underlying technology around it. And also it happens that some of those errors, sometimes they also leak some secrets and sensitive data and so on. So fragments are another feature that can cause a GraphQL feature that is a source of vulnerabilities. Yeah, indeed, we have field suggestion schema leak, which is also really common to GraphQL. So what the problem here, that in GraphQL you have what is called an introspection command, and it happened that a lot of developers, they tend to close the introspection to make it inaccessible in order to avoid leaking their GraphQL schema. But the problem is that there is another GraphQL feature which is called field suggestion. Field suggestion actually it enables when it is enabled, it enables someone, a hacker, to rebuild completely the GraphQL introspection using some very targeted vocabulary. And there is a tool that is called Clairvoyance, which is dedicated to doing that automatically for everyone. Okay, so I think maybe Tristan, you can come back into the talk and continue. Yeah, cool.
Yeah, sorry everyone.
Glad you're back, Tristan.
Yeah, I was disconnected in the meantime, and I took a while to realize that I was disconnected.
I tried to call you actually. Maybe you can turn off your camera, because I think this is a problem. I had to turn it off too.
Okay, but the worst part was the screen sharing, and so now that I guess it's you that is sharing the screen, it's great.
Yeah, I'm sharing it for you, and you can continue talking. Yeah. Okay, you cannot, it seems. I think you should turn off your camera, Tristan. Well, anyway, in the meantime, let's continue. So as I said, a tool such like Clairvoyance is able to rebuild the full schema from only field suggestion. And this is a really common issue in GraphQL APIs, because if you close your introspection, obviously you don't want it to be leaked in other ways. So you have also to disable field suggestion if you really, really want your schema not to leak. So these are the really common vulnerabilities because that comes from GraphQL features. And you can read more of this on the internet, and we have a full article about that, for example. Okay, so here is a bonus, which is actually concerning sensitive data. Sensitive data, well, is a real issue into GraphQL, because since every data is accessible through a graph and different paths and so on, this is really, really common to see data leaking. Okay, so as we can see, we managed to get back a lot of data from the GraphQL APIs we scanned. Most of it were emails, which is actually not always a problem, and most of the time it's not a problem, in fact. But we also have, and this is more of a problem, we also have a lot of secrets and private keys. When I say secret, it's mainly, they are obviously private keys that are leaking through GraphQL API. So we can see into details on the screen that a lot of things are being found, such as the AWS token, GW token, some passwords, and well, any kind of token. And this is quite common in GraphQL APIs. And we have realized that just the developers, they don't really manage to understand or to fix their access control. Access control in GraphQL is a real challenge. And this is shown by those figures, I would say. And you can really easily using, well, the techniques we've seen before, such as batching and aliasing, you can generate a lot of different requests that were trying to get data from the API, from different kind of queries, mutation, and sources, and so on. And you can easily collect, obviously, a lot of data from GraphQL API very, very quickly. Okay. What's really interesting, since Tristan, you're coming back, what's really interesting here is that all of this has been only done through GET requests, through queries, actually, that are completely unauthenticated. We had no authentication token on any of these APIs, obviously, because they were mainly public. So maybe, Tristan, you want to go on with, okay, I can when I go on to the conclusion, maybe, yeah.
Yeah. So thanks, Antoine, for this. Yeah, absolutely. So what's striking in this whole study is that we only did that using unauthenticated GET requests. So what we did was like Google crawling public websites, and nothing else, nothing more in depth for just exploring GraphQL APIs. And still, we found that many vulnerabilities, that many sensitive data leak. So to conclude, we found and scanned about 1,500 public GraphQL endpoints in the wild using specific techniques that we developed for this research. We found quite numerous vulnerabilities, most frequently GraphQL specific, but not only. There were also injections. There were also 500 errors and other kind of generic APIs vulnerabilities. And what was especially striking is the number of access control flows, how frequent it was that secrets or sensitive data are leaking in GraphQL. So the conclusion is what we should, the industry as a whole, the GraphQL industry as a whole, still have way to improve in order for having industry standards about API security. So we hope to see more tooling and more resources to help developers and security team protect their GraphQL endpoints and the data that flows through it.
Okay.
So thanks everyone for listening to this presentation. We are happy to get in depth about the results in the time that is remaining, and to answer any question if you have. We just covered the surface, but there is a lot to get into details about.
Yeah, and we are going to release all this research. We're going to release it publicly, so you can go through more details. You can come and discuss with us, and obviously we are so sorry about the technical issues like we had.
Okay.
It was we were in hell.
That's on me.
Yeah, I'm so I definitely want to have you guys at the end of the Q&A let everyone know where they can access this research and what you're going to be.
Of course.
I'm assuming on the Escape website. But well, first question, is there a separate set of GraphQL penetration testing tools that you can recommend to people that might be unique to GraphQL versus hacking like REST or SOAP or anything like that?
Absolutely. So that's a great question, and we actually maintain an open source repository which is called Awesome GraphQL Security.
Oh, cool.
And it's a public list, collaborative. You can contribute to it, and it contains a lot of tooling that can be used for securing and penetration testing GraphQL. So I will send the link in the chat. I believe it can be useful.
Yeah, that would be great. And also, like, if you guys post on Twitter, LinkedIn, just tag hashtag Apisecure 2023.
Of course.
People who are monitoring that can find those tools and post. But again, I'm assuming you'll also probably post it on Escape. What made you want to start a security company focused on GraphQL security specifically?
Oh, that's a great question. So there were several reasons at the same time for us to focus on GraphQL. The first one was it was asked by the companies we were talking to when we started Escape. Companies were like, "Yeah, you do API security, but do you do GraphQL?" Like, especially,
it's always like, oh, please tell me you know GraphQL.
Yeah. Especially fintech companies, because there are a bunch of fintech companies out there that started using GraphQL, and then they realized that security for GraphQL was still at the very beginning.
Right.
So they were like, "Oh yeah, we need to improve that part because we handle sensitive financial information." So that's how we got the idea. And then also a reason is that we loved GraphQL. We loved trying new things, and we loved how easy it was to query data with the language and how innovative it was. So it was kind of a bet and a challenge as well to go into the security of this brand new thing.
Yeah, no, I'm super excited that you guys covered this. I feel like, and I think I talked about this when we first met, was that there's so much content out there about hacking RESTful APIs and other technologies. There just is a lack of content on hacking GraphQL. So I'm really glad that you guys chose to do this workshop and speak on stage today. So another question: we all know very well the OWASP API security top 10. Do you feel that those vulnerabilities within the API security top 10 sufficiently cover sort of what you guys are seeing on the GraphQL side? Do you feel like GraphQL APIs need their own set of vulnerability lists outside of that?
Yeah, there is something specific about GraphQL and OWASP, is that OWASP is dedicated to web applications, for the security of web applications, and more specifically, OWASP Top 10 for APIs is dedicated to APIs. But GraphQL is an API technology, but at the same time, it's a language. So there is also like all the language part that is not really handled by the OWASP Top 10. And we can see that this is often overlooked by companies, because we have more than half of the public GraphQL endpoints that are vulnerable to malicious queries that were built on purpose for attacking GraphQL. So I think the language nature of GraphQL, the programming language nature, is often overlooked by OWASP Top 10 in this current state. Perhaps we can see it evolve in the long run if GraphQL continues to gain popularity.
Yeah, no, I completely agree. And then, the final question that we've got here is: are there more severe vulnerabilities in GraphQL that are maybe unique to GraphQL than other types of APIs like REST and SOAP? For example, are you, if you find vulnerable GraphQL APIs, are you finding a bigger stash of crown jewels, sort of thing?
Yeah, Antoine, you want to answer that question?
No, you can go for it. It's okay.
So, generally, if I understand well, generally what we find is that GraphQL APIs are vulnerable, and they also carry the vulnerabilities of the underlying other candidates that are behind.
Did we lose?
Okay. Yeah. So, but anyway, what he wanted to say, I think, is that indeed in GraphQL there are some things that are really specific, and we covered them maximum through this workshop. The fact that GraphQL is a graph and allows to query a lot of information at the same time, obviously, it definitely creates new kind of vulnerabilities into the API, and especially concerning rate limiting issues, DOS issues, data exposure and leaking issues, and so on.
Yeah. Yeah. Well, like I said, I'm really glad that you guys spoke today. I want to apologize to the audience for all the technical issues. So Antoine, where can everyone find you and your partner, get access to Escape, research data, all of this stuff, all of the cool things that you guys unveiled today? Oh no, we lost Antoine. This is funny. We're switching back and forth.
Here I am. Can you hear me?
Yeah, okay. Yeah.
So most of our research will be available on our blog. Okay. We are going to put the slides in a blog post following this conference. The tools, they are all in our GitHub. And if you want to discuss with us, we are available on Twitter. We are available we have a Discord community which is quite active about hacking and securing GraphQL APIs.
Oh, very cool.
You can find all this on our website quite easily.
Yeah,
escape.tech.
Why don't I talk with you and Tristan offline, and we'll get your research information and tools and the Discord channel, all that stuff. We'll get all of that together and put that also on the Apisecure website.
Absolutely. And I see a question. Does Escape offer a course to find vulnerabilities? So we are preparing a learning center, which is in very, very alpha version for the moment. But yeah, we are preparing a learning center about understanding GraphQL vulnerabilities, but also fixing them, because Escape's audience is both hackers, but also developers.
Wow, very cool. Yeah, no,
cool.
I think we're as defenders, we're all better for everything you guys are doing over there. So thank you so much for bringing awareness to, the community of GraphQL vulnerabilities, how to test for them, the unique tools to GraphQL. So really appreciate you and Tristan, and wish you guys the best of luck, and look forward to having you guys speak here at the conference again.
Of course, we would love to speak again. This time we'll have a perfect internet connection. And
maybe in person next year, hopefully, going back to
I hope it will either be in person, or I will connect like 10 optic fiber to my computer too, in order to not have Sorry for that, and thanks a lot for having us here. It was really great to present the research, and I look forward to continue to publish and help the community.
Awesome. Thanks, guys.
Absolutely. Thank you very much, Alyssa.